All right, welcome back to Mr. P Helps with Precal. This is Unit 3, Topic 3, Lesson number 1. This is the second half of the first lesson. If you remember in the last lesson, we talked about all the different Pythagorean identities, the reciprocals, quotient, Pythagorean. One thing I do need to make sure that I go over, because this was on the last video, was the idea that you can also use the reciprocal of all of these for all the Pythagorean. So I know we talked about how you can manipulate them and move things around and use that as Pythagorean identity, but you can also use the reciprocal of each one. Meaning, so secant squared x is the reciprocal of cosine squared x minus, and the reciprocal of tangent is cotangent squared x equals 1. Or, yeah. So this also works. The reason why it works is because if you do the reciprocal of all three parts, so if you flip all of them, then it's going to stay the same. So if you take this and flip it over 1 over, and then flip this 1 over, and then flip 1, the reciprocal of 1 is also 1. So this might be useful as well. So just keep in mind that not only can you manipulate the way that these three Pythagorean identities look, you can also change them to the reciprocals of each, and that can also be useful. All right, so basically each one of these is basically like a little mini puzzle. So you just have to figure out which one of these identities, and sometimes I might have to actually pause some of these videos every now and then because I might not see it right away, because like I said, it's really just a puzzle. It's about figuring out which one of these identities can you use in order to simplify it. So the first thing I'm going to do is I'm going to FOIL this. So I'm going to multiply. So that's going to give me secant squared of a minus 1 because it's binomials. It's a differences of squares. Now keep in mind also one other thing I want to throw out here is it says secant of a. I know we've used secant of x and secant of theta. And actually you can use anything. You can use alpha, beta, gamma, delta, phi. Phi is actually pretty popular. You can really use anything you want to represent the missing angle. So you can use letters. You can use like x, but it doesn't have to be x as well. All right, so now we have secant squared x, secant squared of a minus 1. So if you look down here, secant squared of theta minus 1 is the answer, which is cotangent. So cotangent squared of a, and that's literally your answer because I'm, wait, sorry. I used the wrong identity. So first question in, already made a mistake. So secant squared of theta minus 1 is tangent squared of a. That's your answer. That's using this Pythagorean identity right here. So the next one is I'm going to use the reciprocal identity. So 1 over cosine squared x. Well, cosine squared x is right here. So that becomes, that's the same thing as secant of x, secant squared of x. That's this using this Pythagorean identity. Reciprocal identity, and then I'm going to subtract 1 over cotangent. Well, cotangent is right here. That's the same thing as tangent of, so that would be minus tangent squared of x. Now, if you look over here, you will notice that that uses Pythagorean identity. I can simplify this again because secant squared x minus, if I move the tangent to the other side, equals 1. The answer is 1. All right, so the next question, 1 minus cosine squared b over cotangent squared b. So I'm going to change each one of these. So cosine of is equal to 1 over secant. So this is 1 minus. So I could change this to this, and cotangent squared b. Cotangent squared b is the same thing as this. Okay, like I did say before, I do always want to make sure that I'm going to choose the best path. There isn't always going to be one path before I do this question. Sometimes there might be more than one way to get to the exact same answer using different Pythagorean identities, and I do want to show using the easiest way. So I'm going to leave the top the way it is instead of using the reciprocal identity, so that's going to leave it cosine squared of b over. Now, like I mentioned, cotangent of b can be changed to cosine squared of b over, this is cotangent, so over sine squared of b. So I'm using this quotient identity. Now, in this case, this is a complex fraction. So I'm going to do this to the side. So I can actually do cosine squared of b over 1 multiplied by the reciprocal. That's leave, change. I'm just dividing fractions. So that would turn into sine squared of b over cosine squared of b. Now, those can be reduced diagonally, and that leaves you with just sine squared of b. Over 1, which just is itself. Now, I could take that even a step further and use Pythagorean's identity, which is 1 minus if I move the sign to the other side. So the answer is cosine squared of b. That is the single answer, simplified as possible, as much as possible. All right, so the next one, sine of x being multiplied by cotangent of x. So sine of x, I'm just going to leave sine of x over 1 multiplied by cotangent of x is the same thing as cosine of x over sine of x. Okay, so you can see this one's actually fairly easy. So these are going to cancel out, and that leaves you with cosine of x, and that's as simplified as you're possibly going to get. Number 2, we have secant of x over, well, secant of x is the same thing as this. And cosecant of x is the same thing as cosecant is this. So if we change these both and we see where that's going to get us, secant of x is going to give me 1 over cosine of x, and cosecant of x is 1 over sine of x. Then I can leave change, so that's going to be the same thing as 1 over cosine of x multiplied by sine of x over 1. Now, if I multiply across, that gives me sine of x over cosine of x. Now, sine of x over cosine of x is the same thing as tangent of x. There's my answer. All right, 1 minus sine squared x. 1 minus sine squared x is, using this Pythagorean identity, is cosine squared x. And then the bottom is cosine of x. Now, cosine squared of x is really cosine of x times cosine of x. And that means you can literally just cancel these out, and you're left with cosine of x as your answer. Okay, so fairly straightforward with those. They get a little bit trickier here on this last page. So sometimes, you just have to stop and think about how am I going to go about simplifying. So cosine of x, okay, so this is cosine of x over 1. I'm just going to put it over 1 for the time being. Plus tangent of x times sine of x. So tangent of x is the same thing as sine of x over cosine of x being multiplied by sine of x. Well, sine of x is the same thing as 1 over cosecant. Okay, but that's not really going to get me anywhere. So I'm just going to leave it sine of x over 1. Okay, so then I can simplify this down. Cosine of x over 1 plus, so this becomes sine squared of x over cosine of x. Okay, so now in order to add things, you have to be able to have the same denominator. So what I'm really going to do here is I'm going to multiply this by cosine of x times cosine of x. I know I put a square there because that's what it's going to turn into. That was a mistake. So I'm going to multiply this by cosine of x times cosine of x, and that's going to give me cosine of squared x over cosine of x plus sine squared of x over cosine of x. Okay, now I'm going to erase because I know this question takes quite a bit of time and effort. So now we have both over cosine of x. So now it becomes cosine of squared of x plus sine squared of x over cosine of x. Whew. Okay, so cosine squared of x plus sine squared of x is 1. So I can now change the top to 1 over cosine of x. And 1 over cosine of x, if we look over here at reciprocal identities, is the same thing as secant of x. There's my final answer after all of that. Let me erase all of this. And let me go to number 6. I hope I took the shortest path on that. I feel like I might not have. I might have done an extra step there. If I did, so be it. I'm sure you will let me know in the comment section. Sine cubed of x plus sine of x times cosine squared of x. Okay, so the first thing I notice is that both of these have at least one sine of x. So I'm going to factor out sine of x, and that's going to give me sine squared of x plus cosine squared of x. Okay, now this one looks a little bit easier because sine of x plus cosine squared of x is 1. Sine of x, this is actually much, much easier, which is really just, this is 1. Sine of x times 1 is just sine of x. And there you go. That was a much easier problem. If you can find the easiest route, that's always best, preferred. But like I said, you can use any of these identities in any order you want. Sometimes it'll just take you more steps to get to the same answer. Cosecant of x minus sine of x. So cosecant of x minus sine of x. Well, I can't use this Pythagorean identity because L would have to be cosecant, cotangent. What you're really doing is looking for relationships. You're looking for two that are put together that kind of gets you somewhere with it. Cosecant of x minus sine of x over cosecant of x. Actually, okay, so I wasn't able to find any shortcuts for this, so I'm just going to change them all to reciprocals. Cosecant of x is the same thing as 1 over sine of x minus sine of x is the same thing as 1 over cosecant of x. And cosecant of x is 1 over cosecant of x. Actually, let me go back a second because I don't think that's really going to get me anywhere. I'm just going to leave this one as minus sine of x. Okay, so that's really over 1. So the next thing I'm going to do is I'm going to change one of these. Well, I'm going to multiply this one by sine of x over sine of x. So times sine of x times sine of x. And that's going to give me the same denominator. So now I have sine squared of x on top, but now I can subtract. Because they're both over sine of x. So now I have 1 minus sine squared of x over sine of x over 1 over, so cosecant, did I do that one properly? Cosecant is 1 over sine of x. Okay, so yeah, this was wrong, mistake, sine of x. Because cosecant right here is 1 over sine of x. All right, so from here, I'm going to change this to multiplication, I suppose. Let's see, 1 minus sine of x. 1 minus sine of squared x is, okay, so this can be changed to cosine squared of x. So this is really cosine squared of x over sine of x over 1 over sine of x. Okay, so then I'm going to use what I know about complex fractions. Cosine squared of x over sine of x multiplied by sine of x over 1. Okay, now it looks like I'm getting somewhere because these can cancel out, and I'm left with just cosine squared of x. And cosine squared of x should be my answer. I believe that's as far as I can take it. All right, last one, number 8. All right, sine of x over cosine of x. So 1 plus sine of x. I look over here, and I'm looking for 1 plus, okay, 1 minus sine of x squared. Okay, so there's no squared, so these really aren't going to get me anywhere. 1 plus, I'm going to have to find this. All right, after looking at it, it looks like I don't really have any options here of making this very simple. If you find one, once again, let me know in the comment section. But to me, it looks like since we have two different denominators and we can't add unless they're the same denominator, it looks like we solve it like we solved rationals, which means we're just going to multiply each fraction by the other. So 1 plus sine of x and multiply this by 1 plus sine of x. Okay, so that's going to make them both cosine of x times 1 plus sine of x. And then on top, so we have, this becomes sine of x times 1 is sine of x plus sine squared of x. And this just becomes cosine squared of x. Okay, now if this plus this put together, so that becomes sine of x plus sine squared of x plus cosine squared of x. Okay, so then we can, let's see, factor out. I can't believe I didn't see that right away. It took me about 5 seconds off screen. That these two, now, if I group these two together and forget about the sine of x, sine squared of x and plus cosine squared of x is 1. So this basically narrows down to 1. Now I just have sine of x plus 1 over this repeated cosine of x times 1 plus sine of x. Okay, so 1 plus sine of x, and this is 1 plus sine of x, so those cancel out. And now I'm left with 1 over cosine of x, and 1 over cosine of x is, I'm at the finish line, secant of x. All of this narrowed down to this, and that took me 15 minutes. Thanks again for watching, and please give it a like to help you learn something about simplifying all of these with trig identities. Thanks again for watching. Have a great day. 15 minutes exactly.